find an inverse derivative function value for a rational function. So in our example, we're being asked to find the derivative of y inverse of 4, given that y of x is equal to negative 11x plus 3 all over negative 5x plus 3, and that y sub 1 equals 4. So right away we can come in and we can identify certain items of this particular example. We can see here that our y sub 0 is going to equal 4. And then at the end, where we see y sub 1 equals 4, well, this 4 is also our y sub 0 value, which makes the 1 our x sub 0 value. And then we can see that we're given the function y of x is equal to negative 11x plus 3 all over negative 5x plus 3. And then we know that our formula for the derivative of inverses is going to be y inverse prime of y sub 0 is equal to 1 over y prime of x sub 0. And based on what we just figured out, we know that y sub 0 is 4. And let's not forget the derivative mark. There we go. And that's going to equal 1 over y prime of our x sub value, which is 1. So according to this formula, the only thing we need to find now is the derivative of our y function at x equals 1. So we're going to do that over here on the side. We know that y of x is going to be negative 11x plus 3 all over negative 5x plus 3. And to take the derivative of this function, we are going to need the quotient rule. Now the quotient rule says that we're going to take the derivative of the top first. So the derivative of negative 11x plus 3 is going to be negative 11. And we're going to multiply that by the denominator, or the bottom, which is negative 5x plus 3, minus the numerator, or the top, 11x plus 3, and then times the derivative of the bottom, which is negative 5, and it's all over negative 5x plus 3, quantity squared. And now if we wanted to, we could go ahead and we could simplify this algebraically, but since we will be plugging in x sub 0 equals 1, that would really just be a waste of time here. So we're just going to go ahead and substitute 1 in right away. So we're going to get negative 11 times negative 5 times 1 plus 3 minus negative 11x, oops, not x, it's a 1. And then times negative 5. And it's all going to be over negative 5 times 1 plus 3, quantity squared. And then we can continue to simplify, giving us negative 11. Negative 5 times 1 is negative 5 plus 3 is negative 2. Minus negative 11 times 1 is negative 11. Negative 11 plus 3 is negative 8 times negative 5. And that is all over negative 1 times 1 is negative 5 plus 3 is negative 2. Negative 2 squared is 4. And then we can keep working this out. So let's see, negative 11 times negative 2 is 22. Minus negative 8 times negative 5 is 40, all over 4. And then we can simplify that to be 18 over 4, or 9 halves. All right, so now that we know y prime of 1, we can substitute that into our derivative. So we're going to get 1 over 9 halves, and we can throw 1 over 9 halves in the calculator to get a inverse derivative of 4 to be 2/9. All right, let's take a look at another one. In this example, we want to find the derivative of the inverse of h at negative 1, given h of x is equal to 3x minus 2 all over negative 2x plus 6, and we're told we have the point negative 4 comma negative 1. So just like before, we'll identify our x sub 0 and y sub 0 first. We can see that our y sub 0 value is going to be negative 1. And we can see that our x sub 0 value is going to be negative 4. And we have a function 3x minus 2 all over negative 2x plus 6. So we'll start with our formula for the derivative of an inverse function. So that's going to be the inverse of h prime of y sub 0 is equal to 1 over h prime of x sub 0. And since we know x sub 0 and y sub 0, we can plug those values in. So h inverse prime of negative 1 is going to be equal to 1 over h prime of negative 4. So now all we need to find the derivative of the inverse is to figure out what h prime of negative 4 is. And we'll work that on this side. We know that h of x is equal to 3x minus 2 over negative 2x plus 6. So we'll take the derivative, and we will have to use the quotient rule here. Quotient rule says take the derivative of the top, which is 3, times the bottom, negative 2x plus 6, minus the top, 3x minus 2, times the derivative of the bottom, which is negative 2, and that is all over the quantity, negative 2x plus 6. And again, if we wanted to simplify this algebraically, we are more than welcome to. However, we can save some time by just substituting x of 0 equals negative 4 in right away. So h prime of negative 4 is going to be 3 times negative 2 times negative 4 plus 6 minus 3 times negative 4 minus 2 times negative 2. And then that is all over negative 2x plus 6. And I totally forgot to square it up here. I believe I said it. But quotient rule always squares the denominator, so we can fix that here. And I forgot to plug 4 into the x value in the denominator because I was caught up on that squared. And this is how mistakes are made. And that doesn't even look like a negative. Let's just start all over with the bottom. So here we go. Let's gone. Almost erased. So we'll have negative 2 times negative 4 plus 6 squared. All right, there we go. Heads on straight. Let's simplify. So this is going to be 3 times negative 2 times negative 4 is negative 8. Negative 8 plus 6 is negative 2. And then minus 3 times negative 4 is negative 12. Negative 12 minus 2 is negative 14. And then times negative 2. And then that's all going to be over negative 2 times negative 4 is negative 8. Negative 8 plus 6 is negative 2 squared. And then we can continue simplifying. 3 times negative 2 is negative 6, minus negative 14 times negative 2 is positive 28, and negative 2 squared is 4. So let's see, this is going to give us negative 34 over 4, or negative 17 halves. And now we can plug that value in for h prime of 4. So we're going to get 1 over negative 17 halves. And we can plug that into our calculator to get a final answer of negative 2 over 17 as the derivative of the inverse of h at negative 1. All right, folks, that is it. That is finding an inverse derivative function value for a rational function.